Okay. So I think we are live now. I'll just
All right.
quickly confirm with others if they are able to hear the live stream and voice.
Mhm.
Okay. So I think we are live now. I'll just
All right.
quickly confirm with others if they are able
I'm here.
to hear the live stream and yeah. So I'll just take a look. Yeah. Okay, I've asked in the live chat, and you can also like use your mobile to see the live chat. There are around 6, 7 people
Uh,
right now.
I have clicked on the link which you sent me, but I'm not able to see the live chat here.
Uh, okay. It's the same link. The link hasn't changed. So
Okay. Can you put a message something there?
should I send it to you on LinkedIn again?
Wait. I'm just hmm.
Okay. Yeah, that's the chat.
Yeah, cool. Just give me a minute.
Okay, so we'll just wait till it. I think everyone has got the link. Okay, people can hear us. Okay, people can hear us.
Yeah, hi.
Okay. Hi. Hello.
Terribly
Okay.
sorry, I accepted, I guess.
Okay. Okay. If at any point if you can get disconnected, I'll add you up again through LinkedIn. No worries.
Cool.
Okay. Just we'll start by like 8 so that everyone is here. Now 8 people are here and yeah, by 8 I think everyone will be here. Around 10, 15 people
Cool.
should be here. Yeah.
Cool.
Okay. I think we can start now.
Hmm.
Okay. Hello everyone. I'm Abhiraj Vaidya. I'm the Joint Secretary of Quant Finance Club. And today we have Ashutosh with us. He's a senior quantitative developer at a trading firm in Mumbai. And he also leads the team for 0 to 1 Trade, which is also a trading firm in Mumbai. And he has plenty of experience working around with trading infrastructures. And he has completed his degree in computer sciences, and along with that he has been he has been actively working with trading firms to get to work on their data pipelines to get data from the exchanges, specifically on the low latency track. He has worked in machine learning sector as well. He has also worked as a Python specialist for Citibank, and now he leads the quantitative development team full time. Along with that, he holds he was a executive member of Computer Society of India in 2018 to 2019. Welcome, Ashutosh. It's great to have you today.
Yeah, hi team. I hope I'm audible.
Yes, everyone is on YouTube live basically. So they in Meet only me and Vedant. Yes.
Yeah. Okay, cool.
Okay.
All right. So thanks for the introduction. First of all, I'm happy to be here, but I should point out that it's whatever I learned or whatever I'm building, I just I stumbled upon there by luck, I guess, and I kept building as I got the opportunity, and from that I know everything what I know right now. So this is maybe I would like to set the expectations right set right away that anything that I built was required a good enough of failures as well before that. So, for example, let's say when we were interacting with exchange or reading the market data which comes from the exchange, we had first few versions of C++ code which was not performant very well, which was not performing very good, and with time we realized, okay, what mistakes did we made, and with time we improved that. And one of the things that Vedant mentioned, I guess, in the introduction was that I am leading the quant team right now in 0 to 1 trade. So 0 to 1 trade is a broking platform. Uh, I would say that in within, if I have to be specific, I'll also say that I am leading the RMS team there. RMS stands for risk management, by the way, which helps you manage your risk of your portfolios and your users portfolio. So just a point that I want to mention before even starting away. So the very first time that when we build the RMS, the amount of time that we're taking to do any checks, each order had a latency of, I guess, 100 milliseconds or 200 milliseconds. If you are working in this domain, you'll realize that it's too bad. But I guess with time we did improvements, and we have a very good latency right now. Over the internet, orders takes what, 20 milliseconds right now. This is over the internet, which is a big chunk of that goes into the HTTP request that happens. And our controller to controller latency is, I guess, way lesser than that. But of course, this is when you have a smaller portfolio. With as the portfolio increases, uh, the 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 latency also increased. But the reason that I'm mentioning this thing, that everything that I learned was by making mistakes first. The reason telling you that is there is a very big possibility that whatever I say in this session, I might say that as I might make that statement from the very limited, or let's say the 4 or 5 years of experience from that. But with time, it could be possible that I might get to know that, okay, there is an even better way to do that. So whatever I say here, keep an open. Be curious and try to question me as well. Like it's not necessary that what I mentioned here is the absolute truth. Maybe you can do something even better than what I have built.
Mm.
So just wanted to start with that.
Oh, okay. So yeah, as you
Right,
so we started discussing about RMS, and as mentioned by Ashutosh,
right,
whatever we are discussing today, it's what's happening currently and how he
right,
has or their firm has evolved along with C++ or programming the low latency architectures and what they have learned. So most of the session content today would be based around that and his
right,
learnings from other firms or other experiences as well. But of course, there is a scope that this, however, in future might change. There might be change logs because, as we know, tech is a fast-paced industry. There
right,
is change log
right,
coming in every day, and so, yeah, Ashutosh, as decided in our outline, we were
hmm,
thinking that we would just do a brief of roles and skill mapping, like who does what in quant, research, dev, analyst,
right,
infra.
right, right,
Because Ashutosh, in our previous discussion session, mentioned that students really need to know the bifurcation of these roles in quant because quant itself is not been so diverse or it's not been so like put out actively
right.
into students. So he will now talk about what skills are required for which role specifically and the bifurcations.
Right, right, right. Sure. The reason that we even had this discussion in today's outline was because I think the visibility is very less in this domain. There are not a lot of people who are talking about it, and whatever information we have is very scarce, and it's not put out very transparently to people. So I'll tell you one of my biggest pain point. What happens is I get a lot of requests on LinkedIn, and almost all of them they say, okay, I know Python very well, can I be a quantitative developer? Or they say that in my last company, I'm working as a C++ developer, I'm working on operating systems, and I know that this company had given this much CTC to their quant research, to the fresher quant researchers. How much salary would I get if I already have 2 years of experience with C++? And if you're someone who has spent more than 2 3 years, not even more than 2 3 years, more than a year in this field, that these questions are actually bananas, because the experience that they're talking about or the skill they're talking about does have no relation with the role which they're mentioned. So I thought a very good idea would be to have a conversation like this, where I would put out the mapping between the skill and the role, so that maybe we can refer this before thinking on how to approach people, or before even thinking of how to get a roadmap on to cracking that role. So
Okay, sure.
take the last example. Someone said that I have more than 2+ years of experience building C++ code. This was guy from Seclor. So if you are not aware, Seclor is a machine security system. So a machine security company. So they provide softwares which you can put into which corporates can put into their laptop, so that their employees don't steal their code or don't send emails which are not authorized. So that requires putting restriction on OS level. And they are a very good company, and their developers are actually very smart, and that requires good level of C++ knowledge as well of the operating system. But the question which was asked to me was, if I have 2 years of experience here, and a fresher is gaining, let's say, 1 CR CTC in a quant research role, what would a guy like me would 2+ years of experience would get that? So I want to say that in quant research, the C++ has no bearing. Quant research comes from a mathematical foundation. So it's very much true that people who don't even have knowledge of Python, let alone C++, have been able to crack quant research roles. And same goes for quant developer roles, where if you have Python, or let's say Golang, or JavaScript, or some web development experience, and you want to enter into quant development, because that is development actually, and that does requires a good level of programming knowledge, not the mathematical knowledge or the domain knowledge. So even if you go with the Python or a JavaScript experience, I don't think anyone would entertain you a lot, because that field or the position of a quant developer strictly requires knowledge of low latency languages like Go, like Rust, like C++. And a lot of traditional companies would prefer C++. A lot of latest companies who have started in the last 1 or 2 years would prefer Rust. And I'll say there are a good enough amount of people, good enough amount of openings that I've seen in Go as well. And so if you have taking the first candidate, if you have 2+ years of C++ experience, then try to look for C++ related roles, which is quant development, and try to look for that CTC, and then try to think, okay, how can I crack this role, instead of trying to enter into a quant research role. So I guess if we want to divide the positions or the roles in a quant company, uh, I'm talking about quant roles, not software development or testing or sales roles. I'm talking about positions which fall under the quant map or quant umbrella. Then those are quant analyst, quant developer, and quant research. So I guess the highest paying one or the most rewarding one would be quant research, where a good amount of domain knowledge is required. That is a non-negotiable, and a very good amount of mathematics knowledge is required. Again, that is non-negotiable. If you have good enough knowledge of Python, it's a very big plus, or a MATLAB experience, or a R is a language as well. So that experience also helps a lot. In those roles, C++ or other programming languages don't put a lot of weight on your resume. Of course, being a C++ developer gives you an indication that, okay, this is a smart person, but then that is the only use of that language on that resume. Other than that, the skills are not transferable, I guess so.
Okay.
And if you are applying for a quant developer role, then as I mentioned, the three of the low latency languages that I am aware of. Apart from that, I have not seen any positions that have used any other language other than this. And many of
Okay.
times, yeah, I guess someone has a question.
No, okay, one second.
Yeah, sure.
No, I think it was me. I was just saying, yeah, okay. So you can
Mhm.
continue. I do have a question, but
Okay,
I'll
okay.
ask it.
Right, right. I'll just explain quant analyst again, and then maybe we can jump to the question.
Sure.
So the last one that I would say is quant analyst, which I guess is the easiest to crack. Many of times, what happens is I see positions even in tower research. I've seen. I was going through London, the opportunities which are present in London, and they said quant developer hyphen Python. So I would say that the title is little misleading, because that would be a quant analyst role, and that generally requires a very very good knowledge of Python. So I'll tell you the roles and responsibilities that happen there. In fact, if I'm not wrong, my one of my friends in Cube Research, QUBE, not CUBE, he is actively hiring for Python, a quant analyst role with Python specialist right now in Mumbai. So if anyone of you are interested, you can check out their openings.
Okay.
That in
Okay.
that role, a lot of statistical analysis is required, and statistical analysis with use of Python is required. So you should
Okay.
be really good at NumPy, Pandas, Polars, Dask. If you are aware, these are Polars and Dask are frameworks, I guess, which are better than Pandas, faster than Pandas. And if you have some knowledge of the domain, that is good in that would be helpful, because a part of the JD also, or one of the responsibilities within the JD also includes doing backtesting on the strategies, existing strategies, optimizing existing strategies, or helping quant researchers with coming up with new strategies. So of course, if you already know what a call is, or what a put is, or what a strangle
Hmm.
cell is, that would be helpful in that role. And
Okay.
apart from that, if you also have data engineering basics knowledge, then that would be, for example, SQL or Spark knowledge. That is also very helpful, because a lot of time you are doing, of course, you are doing statistical analysis, but you are doing on a very huge amount of market data, and
Okay.
that requires sometimes transformation of data or gathering the data. Which, if you have data engineering principles ready with you, then it makes that process very easy. So
Okay.
the even data engineering skills are a very big plus on roles which require which requires Python knowledge, and those are generally titled under quant analyst role.
Okay. So I just had a question regarding the quant trader role specifically. In
Right,
India, there are quant analyst roles given by like companies in Mumbai. Like there are some, there's Axela, there
right,
is Futures First. They have sufficient amount of quant analyst roles and researcher roles as well. And quant developer roles are given by like good amount of companies like Graviton, Orange Quant, no, AlphaGraph and etc., which
right,
specifically have IIT as their barrier. I won't go into that IIT barrier, but I want to ask about what do you think of quant trader role in India specifically? Because companies like
right,
QRT and such hedge funds, of course, they have such roles where they hire from premium institutions abroad. But do you think
right,
quant trader would be more of a role that is going to open up due to this, like everything being most of the Indian markets being automated nowadays? Like a lot of algo trading is now happening. So do you think, what do you
right.
think of quant trader roles, specifically in these Indian firms like Alpha Grab, Graviton? Because I've not seen anyone work as a quant trader in these firms. Mm.
Yeah, yeah. I wouldn't lie. Right now, the number of opportunities is very less. And when you say that down the line, uh, just give me a second. Down the line, we are entering into algo trading domain. I don't think those two have any correlation. Of course,
Okay.
algo trading will continue. Uh, uh, I'll explain my point. So, the algo trading will continue, but uh, a lot of research or a lot of input in algo trading has been given by quant traders. So,
Okay.
for example, if you are working on any strategy, instead of let's say making it overnight and then paying the overnight cost, the traders can suggest you something. The traders can suggest you something like you can exit at 320 and then enter again at if you want to skip that gap up or gap down risk or not. So these insights are given by quant traders.
Oh,
But
okay.
what I have seen is the number of positions are way less, or at least in my circle or in my network, I might not have people who are hiring for quant traders. But of course, there could be another a niche circle who could be hiring for that. But I'm very really unaware of that. But I'll say, as far as I have seen, the openings are way less than the quant developers and quant researchers ones.
Yes.
But even with the growth of algo trading, I wouldn't say quant trader roles are would be affected that much, because the insight of the trades comes from the quant trader.
Okay. So the traditional trading that one does using his broker API, which is called like
Right,
algo trading, right? That you write a Python
right,
script and you execute it
right,
using a broker API. Now they have a static IP and every requirement coming up, but that is not what
right,
quant traders do. They do. even like pre-surface analysis of what these algo traders are doing, retail algo traders are doing.
Right,
Okay.
right, right. I would agree. Yeah,
Okay. So I think that is the main difference. So it's not as easy as it looks of algo trading, right? It's not as easy as
right,
algo trading that you do with broker API. Okay.
right, right.
Okay. So
I'll add 2 points here.
okay.
Uh, Regarding
Sure.
algo trading, you mentioned that the retail traders use the developers API provided by a lot of brokers. So, of course, we have two branches. In my company, we have two branches. The essentially AI, which handles the the trading, and the diamond hands or 0 to 1, which does the broking aspect as well. So, I got the opportunity to work on both of the teams, and right now, I'm not leading the team, but I'm working very closely with the developers API team, and I think that our team is building something very interesting. So I have not seen somewhere any other broker do this, but we are entering into the vibe trading segment as well. So I guess we'll launch that feature soon. It's still in beta, but what I've
Okay.
seen the team developers, the trader, instead of writing the code or hiring a developer to write that algo code, they would come to our platform. They would enter into the chatbot the requirements that they have, the entry and exit conditions, and the AI chat would help the trader or the retail trader to on writing the code and then entering and
Okay.
exiting at the correct time as well.
Okay.
So
I just have one
yeah,
thing
yeah,
to add up.
yeah, yeah, sure, sure.
Okay, so as you mentioned regarding this platform that we are building, actually me and Vedant also came together to build something similar, but it wasn't in the same niche.
Yeah,
It was more
okay,
around like you enter the strategy codes and you can backtest it. So you don't have to
right,
write the code. It would backtest
right.
on real data. And I tried doing the same using Claude, like without giving it any data.
Hmm,
I thought Claude
hmm,
has already been pre-trained and has all the
right,
nifty historical data for backtesting, but it later mentioned a
right,
line at bottom that it's using simulated data, simulated 1 minute
right.
time frame data. So that's where we realized
Right,
that
right,
it's not going to use real data. We'll talk about these
right,
platforms
right.
later that we are building. I would like to go to the next point in the outline, which was let me just see. Okay, which was it was Q&A, but I think we will keep that a bit later because if someone joins in and his question is missed, so we don't want that. So yeah,
Yeah,
we
yeah.
had this point called prototype versus production.
Yeah, yeah, sure. Yeah,
Yeah, why real trading systems are way different than
hmm.
what freshers think they are. Okay.
Right, right. So again, I'll say that the reason that I added discussion again is because of the few pain points that I've been suffering from. So of course, the very in the beginning I mentioned that the reason that we are discussing about the distribution of roles and responsibilities and the skills is because a lot of people come in and ask me. So of course that was something which was very triggering. So I wanted to have that solved. Another thing which I guess bothers me a little is when the freshers join us, there are a lot of things which a 2 year experienced candidate would feel that okay, this is way too basic. But they are not. But the freshers are not aware of that. So we have to sit them down and we have to tell them, okay, the experience of development or the coding that you have is with the prototype systems or the side projects that you have built at college. But in production system, the difference between that prototype and this production system would be 6,000 lines because we have to think of a lot of paths that you didn't have to worry about at the time that you were building. So I thought maybe if I'll cover this and people would be able to see this, then it can help them think into the direction on how the code differs in your project that you build in your college and the projects that are actually deployed. So again, the reason to put that was to actually solve one of the big problems. So I guess I'll share my screen right now because
Okay,
I
sure.
have the outline of this talk already built, and I guess going through that would be a little bit easier.
Okay,
Sure,
sure.
sure. Please share the screen.
Hmm. Yeah, yeah, sure. Uh, Let me know if it is clear.
Okay, I'll just see the chats.
Yes, it is.
It is clear.
Okay, okay, cool. So, So at the top, you can see the very first line that I have written is a talk for engineering students. And the reason that I have added that is because, of course, as I mentioned, these are things that the fresher would or an engineering student would not be aware of. But if you're already 1 year or 2 year experienced candidate who has already deployed code into production, then I guess this topics you would already be aware about. So in that there are I that too I have broken down this into two segments. One is concurrency and one is all of the rest of the problems. So I'll say that concurrency is such a big issue that I had to make it a separate point altogether. So let's talk about the production pitfalls, and then I'll talk about my most favorite part, which would be the concurrency.
Okay, sure.
So you can see that these are few of the problems that we face into production. So I'll skip through this right away and start with the first problem itself, which is persistence. So if you are not aware of what persistent means, then it basically means that the data that your system is supposed to have, it still has that, even if your system crashes. All right. And I'll tell you why that is important. So let's say I'm building an OMS system or I'm building a trading system. What I'll do is I'll say, okay, I need to make it. I'm talking from a point of view of a student. So I'll say that I need it to be very fast. And in order to do that, I think caches is a way better option than DB, because read writing to a cache is way faster than the read writing to a DB. So I'll say, okay, any order that I'll get, I'll put it into a cache, and then I'll send it to the broker, and then based on change in LTP, I'll either exit it or I'll enter into new positions, and whatever the change in LTP would be, I'll check my existing portfolio, like what is the M2M, which is the unrealized loss and unrealized profit, something regarding that. And I would, and that would be working, and I'll place orders and I'll see, okay, my latency is very less. It's 2 milliseconds, 1 millisecond, maybe half of that, 500 nanoseconds or something, and I'll be too happy with that. But the problem is, you can't copy that into production because, yeah, the reason being, think of this: your code is deployed onto a server. It's with let's say any cloud provider or with your own server room. What happens if your machine goes down? Your entirety of the portfolio was present into a cache, and as soon as the server restarts, your entire data is gone. So you then realize, okay, you can't actually rely on that. You can't actually rely on cache. So you do need some kind of persistence where you need to store that data onto a disk, so that if something like this happens, something like a server crash happens, you are able to reload all your portfolio, and then you can move ahead from that. So you will say, okay, Ashutosh, that is all right. But what happens when, as soon as I need to place an order, first I make a DB entry, and that DB call itself can take, let's say, 200 milliseconds. So the time of order, the latency with the order placement would get too much. So I'll say, okay, so there is something called as hot path and there is something called as cold path. So I won't explain that. I'll just ask you to go through that, and I'll ask you to brainstorm on that. And the reason that I'm not entering a lot into that much is because of the same point, which I mentioned at the beginning of the talk altogether. That a lot of things that I learned was after making a mistake and then learning. So I would really want you to also get to walk onto that path, because maybe my learnings are outdated, not necessarily, but maybe that is. And I would really hope that you would be able to find something way faster or way better than what I have learned while building this trading setup. So I won't enter. So if you can see here, I have not mentioned any solution here. I have just mentioned the problem.
Okay.
But as a starting point, I'll say learn about hot path and cold path, and then maybe that gives you an idea what to do.
Okay, sure. So,
All right, good. I'll go to the next. Yeah.
yeah.
Okay, so next problem is idempotency. I guess we would have learned somewhere in our engineering syllabus, but at least I remember learning about this, but I didn't pay too much attention. And when I was building on things, and then I realized, okay, the exact problem which is mentioned here, there could be a network blip. And let's say you place a order of quantity 1,000, and you get a trade message saying that, okay, 100 of that quantity is traded. So you update that order to saying that, okay, 100 of that 1,000 order is filled. But what happens if you get the same message 4 times? Do you know that 400 quantity is filled, or do you know that this was the same message that happened 4 times? So this problem would be called idempotency, and then again the starting point to solve this is something called as idempotency key. With each incoming data or a packet, you need to assign it a key, and such that whenever the same packet comes again, it would have the same key. So you have that key already with you, so you know that okay, whatever data that whatever packet that I'm getting, I've already handled for this, so I don't need to handle it again.
Okay.
If
So
this is clear, I'll go ahead.
okay, so basically
Yeah,
assigning
yeah.
unique keys.
You
Okay,
have
Vedant has
any-
a question. Vedant has a question.
Yeah, so I have a question.
okay.
So while making these systems, the way you said the message or message type or the the labeling. So how do you make such systems? Like when finance is a very regulated field where government has a
Hmm.
very specific requirements that how a message should be labeled or how it should be the request should be processed. Then how do you make such systems when the requirements of SEBI are so complicated? So how do you make that?
Right. Right. So of course, compliance is a very big part of trading infrastructure, and fintech, I guess, I would say is highly regulated, and with time the regulation only increases. I was never seen SEBI relaxing its conditions. So the very first thing is, even before starting something, the first thing that you need to do is sit with your compliance team and understand everything. And with that, I guess. Okay, so think of it this way: when you are building a project, you will say the primary requirement would be it should not take too much time. The latency should be very less. We think of it as the primary requirement is that all the regulations are followed. That becomes the primary requirement. So the north star that we have while building this project, while building any project, becomes the compliance, and everything then comes afterwards. And when that happens, the system that you design automatically solves for that. So when the first thing that you are solving for is the rules and not the trading setup itself, everything falls under place from there.
Okay, so keep your rules as your baseline primary. Like everything you do, refer to the
Yeah,
rules.
yeah.
Like
Keep that
implement.
as a north star. Like, yeah,
Okay.
if I'm moving, I'll look towards that, and then I'll move.
Okay. Okay. And yeah, again, to summarize with idempotency, you assign unique keys so that don't get confused whether it is getting, even if it is gets replicated, you have the unique key with you so you can cross check and verify. Okay, I think we can move forward.
Right. Okay. So back pressure, which means that I made a system. Let's say I made a queue or something where I'll say in this queue I'll keep putting all the data that I'm getting, and with time and in real time I'm going to process that as well. So there could be incidents where if you would have thought of receiving 1,000 packet in a second, there could come a scenario where you are suddenly getting 20,000 packets, or maybe 50K packets. So what happens in that case? You need to realize that any pipeline that you have, that can get overwhelmed, and then you need to think of that. Then you need to decide, okay, what there are two solutions that I have here. Do I drop the packets or do I handle them? So I mentioned, I guess, not a solution, but a follow-up point on that, that you then if the classification is based on that, I cannot drop any of this, and I definitely need to process this, then have a separate stream for that, and then have a stream for the kind of data that you think, okay, if worst case scenario, if I'm getting too much of it, then I need to stop dropping it, so that my queue is free, so that I can process the more important ones. Again, this is just a starting point. You need to start from here, and then build on top of that.
Okay.
uh, cool.
I think we can.
I guess this is Yeah, I guess the linked CPU is one of the cases which is very rarely discussed, and I want to really shed some light on it. So if you remember on the preview, I didn't mention this. Okay, it's
Right.
there. Oh, sorry, the connectivity is not there. This is else, something else. Okay, the limb CPU is yeah, all right. So your system is working, and you have there is something called as observability. If you are aware, there is an ELK stack, and altogether an entire development system and companies which are built entirely on that. And what it does is it helps you figure out issues with your system. So let's say your server crashes, then there is an observability system which tells you that your server is crashed and you now need to manually intervene there. So I say, okay, all right, we have that. But what happens when it doesn't crashes? But it should have crashed ideally. So something
Okay.
like, let's say you have placed a request and generally you would want it to be solved within 5 milliseconds. But your CPU has got your CPU is overwhelmed with the amount of data that you have received, and because of that, it is now acting. It will start to act slowly, but it is not at slow that that it will restart or that it will crash. So what happens here is you are not even aware right now that there is something wrong with the system. Of course, you can make your observability even better to track this as well, but generally, but there are instances where people tend to miss that. So I
Right.
want to mention that it's not just that your server is running or not. You should also try to see if the requests that are happening with the under the constraints that you have decided or not. Because if you don't check that, then of course your orders are not getting rejected, but then your orders are taking 2 seconds to execute, and that is way worse than the server crashing and then starting again and then acting correctly from that point on. So in your
Okay.
observability, which is your monitoring stack, you can search ELK and what that does. You need to also track for these things.
Okay. You said something about you need to search. I didn't get that. You need to search ALT. Was it? Did I get it right?
ELK, yeah, sure. I'll write that here. I think I've added in chat.
Okay.
ELK.
ELK. Okay.
Yeah, yeah.
Yeah.
It's you can it's a quite famous thing.
Okay.
You'll get to know that.
Okay. So
Basically,
basically,
you can search Elastic Search and you will get to know.
okay. Okay. So yeah.
The acronym is Elastic, Logstash, and Kibana.
Okay.
So Elastic is more like a engine, and the Logstash is the pipeline which connects your engine to your system, which sends it the log and which sends it the metrics. And Kibana is a UI on top of that. So on Kibana you see the reports. On Engine you actually have those data or the metrics, and Logstash is the one responsible to getting that metrics into the Elastic.
Okay. So okay. To
Right.
summarize with
And 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 this,
LMCPU.
and this is yeah, I'll add. And this is a very well known and very well monitored system. I will say people have figured out to great things into this. Like this is very common. This becomes very common as soon as you enter into production or as soon as you enter into full
Okay.
time roles.
Okay. We'll definitely read about ELK. Also try to
Yeah, sure.
have a like go through it in the club as well. So yeah, guys, like as mentioned about LEM CPU, it's a I think it's a silent killer, right? Your server
Right.
isn't
Silent.
crash, but it's producing latencies, and maybe your I think mean latency itself is getting so high. That means the average of all latency itself is going so high, but it's not crashing. But yeah, it's catastrophic because
Right.
I
Yeah.
as
You would
okay.
rather you would rather it crash than it do
Yeah,
something like this.
because
Because if
yeah, go ahead, go ahead. I want to interrupt. Yeah,
that's it. That's it. You can continue.
yeah, yeah. I was just saying that because trading infrastructures are latency critical as opposed to latency sensitive, right? So
Right.
I
Right.
think yeah, if you can continue what you were
Cool.
saying with, we can also move on.
And connect. Yeah. Yeah. And connectivity. Yeah. Sure. Sure. Yeah, well, we can move on, I guess. I was just complimenting your statement there. So the next part is connectivity, and I'll say that this is something that people tend to miss, or I would say not a lot of attention is being given into this. But I'll say this: you need to have a process in place or a system in place, not that you know exactly what to do when your connection drops down. So whenever even me, whenever I was in building a project in engineering days, I would always assume that the pipeline is stable and it will always be stable. So any from any place, if I'm getting any data, my assumption was, or let's say unknowingly, subconsciously, I always believed that that pipeline would never get hindered. But that doesn't happen if you're connecting with exchange, like we don't have a broker in between. We are the brokers. So with us, we directly connect to the exchange and we do a login with them. We are getting the data, or let's say we are there is another stream where we are sending the orders to them. It can also happen that the stream through which I'm sending them orders is broken down. In that case, so what I'm of course everyone knows that that can happen. What I'm saying is you need to have a system in place to know that what exactly you need to do when that pipeline goes down. So instead of when it goes down, your observability system telling you that this has went down, and then you start to decide, okay, what do I need to do here? Instead of that, already have a plan in mind that if this happens, these are the very specific steps that I need to do, and within them steps you are able to reconnect, or you're able to get back to the previous state. So the key thing here is that process, or that set of steps that needs to be determined before that event happens, which I've generally seen. Uh, I've generally not seen in lot of places. So the idea is just to have that process already figured out instead of thinking what to do when that happens.
Okay. I think Vedant had a doubt.
Yeah, so
Yeah, sure.
my question was that what tech stack or what languages, what systems would you prefer to build these low latency systems, which would work great for such kind of requirements?
I think
Right.
we
Cool.
discussed
So
that, but yeah, if you
I guess
could,
that's an excellent. Yeah, that's an excellent question. I did mention what we were using in our company, but I guess I can summarize it. I can summarize all of the tech stacks that we are using. So with Exchange, right away in front of Exchange, we have a C++ system, because if we don't have that, then we observed. We actually did this. We had a Python code there, we had a Go code there, we had a C++ code there, and we realized with Python we were dropping a lot of packets. With Go, we were dropping few packets. With C++, and that too C++ version 14, we were
okay,
able to catch all of the packets, decompress it, then decode it, then send it to the following systems within a time that within such a time that we were not dropping any packets there.
okay,
And
that's
of
good.
course, this is the OMS system, which is the order management system, which directly interacts with the exchange. Then before that, there is RMS or ORS, which is order routing system, and the risk management system. These are clubbed together. So again, as I mentioned, I was leading the team in the risk management, where our job was to take span files and other files that we get from exchange, calculate the risk metrics of portfolio, and then determine if these are the portfolios that need to sustain, or do we need to square it off all, or if there is a new order incoming, then should we even allow this order, or should we reject it, citing that risk issues. So that system we built in Golang, and the reason that we did that was because we wanted to handle a lot of incoming requests from users, or from the place which is sending the orders. And ORS, or the order routing system, is the one which is responsible to create a router which takes that request, does the RMS checks, and then send it to the C++ code, which in turn sends it to the exchange. So we wanted high concurrency into this,
Okay,
and because of which we went with Golang. And the reason for that is, in Golang, concurrency comes natively, or of course it comes natively with all the with a lot of languages, but there is a lot of good support which is present in Golang, which are not present in the other languages. And starting a thread and ending a thread is very easy into Golang as compared to the other languages. And we did check that. Of course, this was not a blind decision based on the theory of the language. Instead, we did run a lot of tests, and I guess there was a dedicated time of, I guess, a month or so for of an entire team testing into the latency aspect as well. And in fact, we very proudly endorse that our RMS system is built in house, and we are the second brokers in India to build a system in house. And the one of the key points for doing that, one of the key points for building that in house, was because we could control the latency game here. We have the entire control onto onto the system. So if with time we realize that, okay, our system is not able to handle a lot of orders, or if the latency is increasing, we directly interact with it and we directly solve the issues instead of our RMS vendor solving that. And in fact, I'll say even Kite doesn't have its own RMS. And I'm not 100% sure on this, but in between, they try to work on that, they try to build that, but due to difficulties and complexities, they have to drop that project. But we did maintain with that. And the entire reason was latency for that,
Okay.
the control and the latency for that. And
Okay.
this was the RMS. And we, of course, I mentioned we get a lot of market incoming ticks. Or tick is, I guess, what people call is LTP, the prices from the exchange. Those are the price of the stocks.
Okay.
So we wanted a system where the writes would be very fast and the reads would not overload the system. So we went with distributed database, which is Cassandra. So if you'll see, Cassandra provides very Cassandra. I'll say one thing about Cassandra. It provides you a fast system, but it's very rigid. Rigid in the sense that before creating the schema, you need to determine what are going to be my queries. So in SQL, you create a table, and after you create a table, you can write any number of queries that you want.
Yes, we
But
can
but
apply
that
that.
is not same for, yeah. In Cassandra, you first need to determine what queries are you are going to run, and as soon as that is fixed, then you write a schema. And if you write any other query from that, and if you write any other query, then other than the one which you have decided, your system is going to perform very bad. In fact, something as small as select star from table where column D equals to X, something as simple as this query can crash us.
Oh, okay.
You can learn about it.
I think sorry to interrupt, but can you explain a bit what Cassandra is? Because I don't think my our users are aware of Cassandra.
Right. So it's a NoSQL database where you don't necessarily have to design a schema, but if you design a schema, that schema can give you very good optimizations on write. So your write optimizations would be very much the I guess the latency to enter a record or insert a record into that DB is 10x or 20x better than other DBs like Mongo for storing something like LTP, which is very huge in size. So it's a
Right.
distributed system where you have multiple nodes, and it has capacity. It has capacity to store data in 100 GBs or in TVs. Whereas you will see that there are certain other databases which start to hang after a big amount of data. So the entire purpose of this database was to handle a bigger amount of data, and hence it's a distributed model. And this comes with both the NoSQL schema and the SQL with non-relational schema and a relational schema as well. But again, as I mentioned, when you enter into the relational schema zone, you realize that okay, now what I'm doing here is I am choosing latency over flexibility. As soon as you enter into the schema aspect of Cassandra, you say that okay, I realize that these are the 5 queries that I want, and apart from that, I'm not going to ask anything. But Cassandra is going to promise me that it is going to give me the best latency over any other databases.
Okay.
So it's a distributed DB which is used for storing a large amount of data.
Okay, I think that was really helpful regarding the DB thing. Especially many people
Great.
didn't knew about this. Even I wasn't aware
Right.
because I've been working with
Yeah.
Postgre, but I was not aware of this. Yeah, I think we can move on because we also have concurrency to cover,
Right.
and it's yeah 8:45, and
Right.
yeah I'm also sort of waiting a bit for that
Yeah. So
off the
yeah. I
record
think
discussion.
I'll wrap this up very quickly so that we can have.
Okay, okay. Oh, I thought this whole PPT was
I don't
going to
think that I
be
don't see that happening because I guess we are losing time.
okay. Okay, we'll still try. We'll see. We can start with concurrency.
Yeah. Sure. So can anyone tell me what's wrong with this code, or in line number 22 when this prints, what will be the value of this count variable?
Okay, I think everyone
Of
in the
course, I'm
YouTube
sorry.
chat.
I'm not taking I'm not taking answers from chat, so I
Okay,
won't even know that what they're saying. But I'll go ahead and say this. If you want to translating this C++ code to this question, basically, if there are 1,000 threads, and I'm assuming that you are aware of the concept of threads here. If not, then just take it as a light session on this. But and if you are but if you are already aware, you can try to maybe answer this question. So if you have 1,000 threads and each of them are trying to increment a shared counter, what would an increment by one value? So what would be the final value? And if you think it would be 1,000, then I'll say no, it won't be. So you can then ask me, okay, what would be the answer? Then I'll say, okay, it's non-deterministic. I cannot tell you what the value could be. And the reason being, there is a race condition happening here. And in order to understand this better, what I'll do is, why don't we do this? We take this count plus plus code and we enter into the assembly instructions of that code. So that one line of code looks like a one line of code to us, but behind the scene in assembly, there are three instructions happening there. Again, this could get a little too tech heavy. So if that is happening, you can take a chill. You can stand back a little and say, okay, maybe I can skip this, or you don't need to get overwhelmed with this. Because I don't think everyone would be understanding
Yeah.
assembly language, but I'll do my best to explain that to you. So just MOV stands for storing value. So, and okay, even before that, what is EX? So consider EX as a storage slot. Think of it as a slot. So what
Okay.
MOV does is it takes the value of count and puts it into that slot. And what INC does is it increases that value by one. And then what MOV does again is it takes the value of the EAX or that storage slot and puts it back into the count. So if you see this code, what's happening here is there are 1,000 threads who are doing this process together.
Okay.
So think of the timeline at t equals to 0. Everyone reaches, not everyone reaches there, but let's say 200 of the threads reach this point. They are now running this assembly instruction, and then they see the count value is currently 0. It's put into that slot. In that slot, they have incremented it by 1, and after that, that 1 is again put into the count. So and now that thread's responsibility is done. But then you see all 200 of those threads are reading the value 0 of that count. They are incrementing it to 1, and then they are storing it back as 1. So even though there were 200 operations, the 200 threads which did this operation, the count is still incremented only by 1.
Okay.
Which is why we cannot surely say that after the end of all the 1,000 operations, we don't even know that what that value could be. That could be 1, or that could be anything between 1 and 1,000. So if it could be 1, if all of the 1,000 threads read the count value 0 together. If that happens, then no matter what
आई
sequence
इथं
other
नको येऊ,
instructions
आत्ता नको
happen,
येऊ,
the
इकडे येऊ
final value
नको,
is definitely
आत्ता नको
going to
येऊ.
be 1.
थांब जरा, दहा
And
मिनिटं
if
थांब, 10 मिनिटं
it
थांब.
so happens that all of that 1,000 threads read this value sequentially, in a way that when the
थांब
first
जरा,
thread was done with its process, the other thread
मी
came
लाईव्ह
and
आहे
read
इथे.
the value. In that case, it would be 1,000. In all other cases, it could be anything between 2 to 999. So
Yeah.
let me know if I'm not sure of what year students are attending this. So if this was too much, you can skip this. But if you are able to understand, that is well and good.
No, I tried to read a bit, like I just Googled this stuff, but most of the, like as you said, it's
Okay.
going to be non-deterministic, and I think the answer to
Right.
this would be that it's mostly going to be less than 1,000 always, considering the
Less than
whole,
1,000. Yes.
yeah. But I think most of the attendees
Right.
are first year and they may not have
Okay.
the get this.
Yeah, you might
But
not be very much aware with how this translates to assembly code or something, so you can just skip
yeah,
this. So
but I
the
have a follow-up
reason I
question.
was even hesitant to put this was because of the same thing, because I don't
आई
know
इथे नको
where you're
बडबड
standing
करू.
right now. So from that point of view, would you even get to understand what I said or not? But again, if you got it, well and good. If not, just don't get overwhelmed, just skip this.
Okay. But yeah, you could just briefly summarize it up that how is it really like affecting the exchanges? Like in what sense? For the first year students, like just to get a practical POV about this concept. You can discuss that aspect maybe. They'll understand more.
I'll instead of giving you solutions or giving you
Okay.
instead, if I'll tell you my learnings on that, again the same point, I can put you into a tunnelized vision, which can then hinder your progress. So what I'll do is I won't tell you the answer. What I'll tell you is you need to start looking into race conditions. So use
Okay.
race condition as a starting point, and then jump from there and see where you reach.
Okay. So
And maybe
basically take it as
probably
a
with time
reset.
you might get better understanding that what I have. So instead
Okay.
of explaining that, I'll give you a starting point.
Okay, starting point. Basically, take this as a baseline, concurrency issues and everything. Okay.
Yeah,
Yeah.
take race condition as the baseline and try to read into that. What is race condition, and in what cases do we get race condition, and how do we solve it?
Okay. So, Ved, okay, I think I'll just start with the Q&A, and then finally, if we have 1 or 2 minutes, you can talk about how you're
Right.
fooling the system.
Yeah, yeah. Can I in this unit, can I start with the question
Yeah,
instead of
sure.
the viewer starting with the question?
Okay. You mean like you asking me?
Okay. Anybody can answer this. Yeah, I'll ask the first question. You ask
Okay.
the second question.
Sure, sure.
Yeah, from their point onwards, you can ask the following questions. But I would like to ask the first question.
Okay.
Anybody can answer. And if I'm missing the answer from the chat, maybe Vedant or someone else can translate
Sure,
or
sure.
bring it to me. So I'll ask: is parallelism and concurrency? What's the deal with parallelism and concurrency? Are they synonyms? Are they just one concept in which two of them have the same? It's different name, but the concept is same, or are they completely different? Or they interact somewhere, that is some part of parallelism matches with some part of concurrency, or is or they are the subset of each other, like parallelism is the bigger umbrella within which there is concurrency, or the concurrency is the bigger umbrella within which there lies parallelism. Can anyone explain me that or help me with that? Anyone here who might be aware of this and would like to take a hit?
Okay. I think they will answer mostly in chat because in Google Meet, as I said, me and Vedant are there. We'll wait. Like
Okay.
maybe they're typing.
Yeah, yeah, right, right. So we can start with an even simpler question. Are they same thing or are they different?
I'm actually, since they being juniors, I'm waiting for them to answer and not answering myself. Mm,
It's all right. You can try that, because I think after if we don't move ahead quickly, I guess we won't have too much time for their Q&As.
Okay, sure. I'll just
Just
submit
just
a
answer this question. Are they same or are they different?
they are
Okay, so
different.
Just
they are
you
different.
just need
Yeah.
to sum it up. Just give me a single sentence.
I
Are
think
they
Vedant,
same? Are they different? They are different. So is anyone a subset of other, or they interact a little?
okay. I think Vedant had started with the answer. We both knew the answer. I think Vedant
Yeah.
goes for it. Answer it off.
Yeah.
Yeah, so both are not related to each other, and I think means I might be wrong, but
Okay.
parallelism is like under the umbrella of concurrency, if I'm not wrong.
You are 100% right.
Okay, thank you.
Okay. Yeah, and for
So
from my part, I think
concurrency is
going.
the bigger set within which there is parallelism.
Yeah. Okay.
And I won't go more into that. Yeah, sure. Go ahead.
Yeah, no, I just saying that concurrency you are doing it on multiple cores, whereas sorry,
Hmm.
parallelism you are executing tasks on multiple cores, whereas concurrency is that you are switching between the multiple tasks. If I have to give it to the audience, yeah, fine, we can continue. We have less time remaining.
Okay. Yeah, both of your statements were correct. I'll just add this. So you said, let's say this vehicle has has size capacity of, let's say, 5%, and this vehicle has petrol capacity of, let's say, 20 liters. You're not comparing them on the same baseline. So you mentioned parallelism having multiple cores, but you didn't mention the corresponding point of concurrency in terms of cores. And then you mentioned concurrency is switching between multiple tasks, which is again correct. But in retrospect, what does parallelism does then? And again, these are just questions. I won't be giving you the answer. I would want you to find an answer for that. So I guess the baseline here that you can start with is, if parallelism uses multiple cores, does concurrency uses multiple cores, or does it use single core, or is the answer depends? It depends on the code, or it depends on the infrastructure. You can start with that and then try to move it from there.
Mm,
And sorry
okay.
for wasting the 3 minutes or 4 minutes of the Q&A. I guess we can start with the Q&A where you can ask me
Okay.
questions.
No, no,
I
I
think
think don't be
for
sorry. It was a great question.
yeah, it was in fact it was back to
Okay.
the basics and yeah, fine. We have
Right,
one
right.
question
Back to
in
the.
chat. We have one question in chat. I think Vedant, if you could narrate it up, asked by
Yeah.
Shreyas, who is our
So,
tech lead sort of in the club.
so we have two questions. First question basically is the question like what recovery mechanism is used after a restart?
What recovery? Okay. This is recovery mechanism from a point of view of a retail trader or a broker or an exchange. Can you give some clarity?
I think he
Okay,
haven't
I'll
gave
answer
a
in a way
clarity.
that
You
it
give a
answers all of
generic
that.
statement.
So of course, if I'll answer from a retail, I, yeah, I'll give you a generic statement. Recovery mechanism in restart should, I wouldn't say what, I would say how, or what is it targeting. The target should be get back to the state where you were before the restart happened, however you can get there. So let's say if you are a retail trader, think of what was the state before the restart. So of course you had a list of orders, you had a list of trades, you had a list of positions, you had a list of targets, or what to do later. So figure out those four requirements, and then as soon as the restart happens, know that four things and get to that state where you again you have all the orders, the trades, the positions, and the targets. Targets as in what you want to do next. Get to that state where you have this again. Keep this in mind and then do whatever it requires to get there.
I have a add-on question on this from my side. So this is about like
Okay.
when it comes to packet tick data. So we usually use TCP,
Right.
TCP, right? TCP UDP combinations. So there, to recover the packet losses, what mechanism is used or what protocol is used to recover the lost packets?
Yeah, and I also have one
Right.
thing to add up. We had you, as you said, like we will have a discussion on TCP. I think we can add this up as a like good concluding points on TCP. Basically, a small TCP
Right.
discussion
Right.
as well. Yeah.
Right. Right. Cool. So, if you don't mind, I would like to stretch this answer a little. Uh, the question which you mentioned, the tick data that we take it from TCP. The reason that I wanted to have this session is again because again to clarify these questions, which is uh, what do we do when our line goes down. So first of all, you try to understand the constraint and the requirements, and basis that you realize okay what we can do when things fail. So when you are receiving tick, what happens is the number of instruments are way too much that receiving those data from a TCP would literally bring your system down, or at least it will 10x or 20x your infrastructure cost, which is why you don't get the market data from TCP, you get it from UDP. And the orders that you get from exchange, that you get from TCP. And of course, in one of the points I mentioned, you need to separate your streams in a way where you realize, okay, I need to make a decision, a conscious decisions on what packets I am okay with missing and what packets I'm not okay with missing. So in this domain, what people generally do is, or not generally, what happens is, or what the law is the connection with the exchange, the UDP connection with the exchange. When that breaks, you are okay with the packet loss. You move ahead with that. You say, okay, whatever data, whatever LTP data that I was supposed to get, I'm not going to get that. But from now on, as soon as I restart, whatever the new LTP which I get, I'll start from there. But with the TCP connection, you know for a fact that that TCP connection was giving you packets which you cannot miss at any chance. So as soon as a restart happens, exchange is also aware that there could be scenarios where the TCP link between the exchange and the trading party can go down. So they do provide provisions where when that happens and when you restart, they give you the right to ask all the data that exchange has been sending from a timestamp. For example, the last timestamp that you have is of 2 hours ago, and you say generally you don't have that big of a timestamp. You say last time when your system was stable was 10 minutes ago. So you tell to the exchange that okay, from that point of onwards, whatever TCP packets that you send me again, so that I'll see that during the time when you had a downtime, was there any packet that you had missed, and you get that packet, and then you try to get to the state. So this is what you do.
Okay.
Okay, that's a great. That's like really helpful.
Mm, okay.
Right.
So
Unfortunately, due to lack of time, I'll say I can take up, I guess, two more questions. If you have any more than that, you can try to approach me on LinkedIn. I guess right now, due to number of requests that I've been getting, I'm not able to accept more than like 3 or 4 requests in a day. Like there is a limitation on the number of requests that I can even accept. So maybe like try to
yeah, sure.
we can have a post or something where you can ask questions and comment, and I can reply
Yeah.
from there, or you can
I
tag me
think
or something.
I think we
Any questions after that two question, you can try to approach me there.
I think
Okay, sure. I
we
will.
just
We will
chat.
share your ID and all
Yeah.
your like details to our team.
Yeah, I think we can
Yeah,
start
right,
like
right.
end with the concluding remarks now. I think it's a 1 hour session. I think it has been great.
Okay,
So much has been discussed, and I think it has just been
right,
pure informative, even to me, and
right.
especially everything
Right.
related to the DB
Yeah, yeah.
or the
Before
TCP. So it's
I'll
like
say before moving ahead,
yeah,
if you guys, yeah, if you guys have time, I would like you to, yeah, I would like you to visit this 021.trade. That is our
yeah,
B2C broking system. Also, there is B2B segment as well, but I don't assume that first year engineering students would be running a businesses right now in fintech. So you can visit us. You can create an account. You can trade with us. You can learn with us. You can teach us. You can comment us or give us feedbacks.
yeah,
And I would be looking forward to meet you there.
yeah.
You
Okay.
can continue now.
Yeah, I just have one last question. Okay, it's my own question. I recalled it now. What
Sure.
projects should
Yeah.
aspiring quant developers build to get into even mid-sized firms as well as firms abroad or good Indian firms as specifically as a quant developer? Like you have a friend who is in QRT, right? So what sort of projects they expect?
Right.
Or is it just pure DSA based hiring? Because we know the weightage for DSA these guys have. But what project should we build? Like we
Right.
are
Right.
building some limit order book projects. Then I was building some AD address family XDP kernel bypass project. But we ourselves are very confused on like regarding low latency specifically and HFT, what projects should we build as a club?
Mhm.
If you could conclude with that, it would be
Right.
great.
Right. 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 Sure. So instead of saying what you should build, I'll say what me and my friends built, and maybe that if that was relevant 5 years ago, I think that could be relevant now as well. So of course, the order matching is like the hello world in this domain. So that is a must. You should start with that first. And when that is done, I guess I had a friend in our final year projects. I had a friend who built a C++ plotter, a graph plotter. He finished that. He built that project. Using that project, he got an MS right away. So that is a very good project. I luckily got an internship in third year from college itself, of course, in ML, and that was an NLP project. So even though machine learning doesn't really translate right away with an HFT system, those kind of projects are considered heavy, tech heavy, and that also requires a good amount of math knowledge. So I guess even ML projects are good. Math heavy ML projects are considered, not the ones where you import a library and you really ask the model to just train it on a data, where you make the model yourself. Even those projects are very good. And then X simulators is a good project. One of my friends built that as well. And yeah, I guess something around these lines, these projects would really help brighten your resume.
Okay.
Okay.
So yeah, that was
So I think if we don't have any more questions, let's conclude the session. So on the behalf of the
Sure.
Quant Club, me as a secretary, I would really thank Ashutosh Tiwari to for taking out his time from his schedule and to conduct this session for us. I mean, I really appreciate it, and we have learned a lot. And you have given us a really great insights, great topics to think about, to learn about, and it would be really great if we can have a connection where we ask our questions and you can like keep helping us, and that would be really great. So really thanks to you for joining this session and conducting it. Thank you.
yeah, Ashutosh. Thank you for being here, and I hope
Yeah.
that
Thanks.
this connection doesn't end in this session itself. We continue to have such more meaningful connections with COEP University and other firms and people like you. Thank you for being with us.
Thanks, Abhiraj. Thanks, Vedant. In fact, I'm happy as well that you reached out to me. This was a pleasant experience, and I really hope that I was able to make you come up with the right questions. Of course, as I mentioned in the beginning, I won't be giving you a lot of answers because my own answers I got by doing something. So I would want you to do something and then come up with the answer. So again, the purpose, I guess my objective in this call would be to move you into the right direction where you start asking good questions. Not to me or in this Q&A, but in general, if this problem is there, why is it there? What can I do to solve it? What should be my next step? What others could have been doing? Something like this. And I hope that of course we'll with this you learn something, and the next time that the next session that we can build up on top of this, and we can I guess try to cover things on the next level.
Sure, definitely. Okay.
Sure, definitely.
Yeah. Thank you for being with us, and good night. And yeah,
Bye, team.
bye, team.
Bye.